Hello there and welcome back. So in the previous videos we have created our room database, we have created our recipes entity, our type converter, our database, our DAO interface, and now it is time to create a new module inside our dependency injection package here. So I'm going to create a new object, and I'm going to name this object database module. And inside this module, we're going to tell our Hilt library how to provide our room database builder and our recipes DAO. So first we need to add two annotations on our database module. So if we open up this network module, you're going to see that we have those two annotations, and we're going to add them here as well. So just copy them and paste them here. Okay, and now we're going to create two functions to tell our Hilt library how to provide room database builder and our recipes DAO. So first let's create a function named provide database, and as a parameter we're going to add the application context. So we're going to use this annotation from our Hilt library, so we can inject this application context immediately. Okay, so context, alright. And so this function should return room.database builder, and here we need to pass three parameters. The first one is context from our provide database function. The next one is the actual database, so recipes database. Okay, so this is our class which we have created, and this class is annotated with this database annotation. And the third parameter is the actual name of our database. So we have already specified the name of our database inside the constants class, as you can see here, under this constant database name. So here I'm going to paste that name and just import this, Alt plus Enter, okay. And finally I'm going to call a build function at the end. So this function will provide our room database builder, and we need to annotate this function with singleton and with provides annotation as well, because the room library is not our class, it is a third-party class. So I'm going to down below create one more function named provide DAO. So this function will have one parameter, and that is a database, our recipes database, and I'm going to return database.recipe DAO. Okay, so inside our recipes database we have this abstract function, and basically we're calling that function from here. And of course we're going to add those two annotations as well, so singleton and provides. So this is how our database module should look like for now. We have basically told our Hilt library how to provide our room database builder and our recipes DAO through this database. So as you can see, we needed to satisfy this dependency in order to provide our DAO. So later in this course we will easily inject this DAO into other classes. So that will be all for this video, and in the next video we're going to continue by creating a local data source probably. So that's all for now. Hello there and welcome back. So in the previous video we have created our database module, and we have told our Hilt library how to provide the database and our recipes DAO. So in this video we need to create a local data source. So we have already created the remote data source, and as you can see, this remote data source is injected with this food recipes API, and that food recipes API contains this one get request for now. And now it is time for us to create a local data source and inject this recipes DAO inside it. And we should be able to inject this recipes DAO because we have already told our Hilt library how to do that. Okay, so now I'm going to create a new class inside this data package. Okay, and I'm going to name this class a local data source. Okay. So first we need to add the inject annotation. Okay, so add constructor keyword here as well. And here we need to inject our recipes DAO. So recipes DAO, this one. Okay, and inside this local data source we need to create one function for inserting the recipes into the database. So I'm going to create function named insert recipes. And this function should have one parameter, and that is a recipes entity, which we have already created. And inside this we're going to call this recipes DAO, and we're going to call this insert recipes function from our DAO class or DAO interface. And here we need to pass our recipes entity, of course. So we have a warning here telling us that this function is actually suspend function. So now we need to add suspend keyword here as well. And as you can see, basically in our local data source, we are calling this insert recipes from this recipes DAO. So this is the one. So here we're going to create a new suspend function named read database. We're not going to have any parameters here, but we're going to return here a flow. So select this one, flow of a list of recipes entity. Okay, and here we're going to return recipes DAO.read recipes. Okay, so we can actually remove this suspend keyword because we don't actually need on this read database. And basically our local data source will contain all the queries from our recipes DAO, because we have injected that recipes DAO here. And for now, for reading the database, we're using a flow. But in the main view model later, we should be able to change that to live data. Okay, so that will be all for this local data source. And now I'm going to open up this repository so I can actually inject this local data source in this repository as well. So here, so far we have injected this remote data source. And now I'm going to inject this local data source as well. Okay, and down below I'm going to create one more variable named local. And I'm going to store this local data source inside this local variable. And in the next video, we're going to call this local data source from our main view model. But for this video, that will be all. Hello there and welcome back. So in the previous videos we have created our local data source and we have injected that local data source in our repository. And now in this video we need to use this local data source to actually cache our data from our API, so we can actually access our recipes even if our device is offline. So basically we're going to implement offline caching here, and offline caching will be implemented here in our main view model. So whenever we fetch a new data from our API, we need to cache that data immediately. So before we start implementing our offline caching here, I just want to make one comment here. Okay, and here I'm going to write retrofit. So this section down below will be for retrofit, and on the top I'm going to add one more comment. Okay, and here I'm going to write room database. Okay, so we can distinguish those two. So first what I'm going to do, I'm going to use a local data source to actually get to my room database. So I'm going to first create a new variable here named read recipes, and the type of this variable should be a live data. And here we're going to say list of recipes entity. Okay, so here we're going to use a repository.local.read database, and as you can see we have a warning here telling us that our variable type is a live data, and here we have a flow. So there is an extension function which we can use to convert our flow to a live data. So just press dot as live data. Okay, and that's all you need to do. And now this warning will disappear, of course. Okay, so here from main view model we have basically called this read database function from our DAO interface. And down below I need to create one function for inserting the data in our database. So let me just add a private function, insert recipes. So this function will have one parameter, and that is a recipes entity. Okay. And here we're going to use a view model scope to actually run a Kotlin coroutine. So launch. Okay. And before that we can specify the actual dispatcher. So I'm going to say dispatcher.io because we are running a database work. And from here I'm going to call repository.local, of course, .insert recipes. And here I'm going to pass this recipes entity from the parameters of this function. So after that we need to scroll down below until we find the get recipes save call function, and here it is. So next inside this try block we need to add one function, and that function will basically handle offline caching of our recipes from API. So here in this get recipes save call we want to cache our data immediately after we receive it. So down below first I'm going to create a new variable named food recipe. And here I'm going to call this recipes response dot value.data, and here I'm going to check if this food recipe is not null, and if it is not null, then I'm going to call one function named offline cache recipes, and I'm going to pass this food recipe. So basically here we are checking if our response is not null, so that means that there is a data, and if there is a data, we want to cache our response into our database. So let's create a new function here. Okay, so as you can see, this function has one parameter, and that is a food recipe. So I'm going to create now a new variable here named recipes entity. So recipes entity, and I'm going to create here one recipe entity of this food recipe. So just pass this food recipe, and as you can see, our recipes entity, let me just open that, has one field, and that is a food recipe, okay? So that means that this is one and only column which we're going to have in our database, except this ID, of course. And basically, in order to insert our data to database, we need to convert this food recipe into this recipes entity, and that's why we have set this food recipe in the parameters, and here we have created our recipes entity, and now we can insert this into our database. So here we can just call this function which we just created, insert recipes, and let's just pass this recipes entity. And as you can see, this is the actual function which we have already created here, and this function is basically calling this insert recipes function from our local data source, and we are storing our data into our database. So basically, whenever we fetch a new data from our API, we're going to cache that data immediately. And in the next video, we're going to handle our recipes fragment, where we're going to read our database instead of requesting a new data every time. So you will see. And for now, that will be all. So here, as you can see, we have created one function for inserting recipes and one variable for reading our database. And we're going to use this variable later in our recipes fragment. And here inside this get recipe save call, we have checking here if our food recipe is not null, and if it is not null, then we are calling this offline cache recipes, where we are basically caching our data. So it is very simple, and that will be all for this video. In the next video, we're going to handle the actual recipes fragment. Hello there, and welcome back. So in the previous video we have modified our main view model class. So here we have added a new section for a room database, and I have added one function for inserting the recipes into our database, and one variable for reading our database as well. So down below we have also created one new function named offline cache recipes, and this function will basically wait for our API to get the data, and when we get the data we want to store that data inside our database. So whenever we request a new data from our API for new recipes, then we're going to store all those new recipes in this database and replace the old data. So our database will have only one row, and that row will be replaced every time we get new data. So now that we have created all of that, we're going to open up a recipes fragment. And here, as you can see, for now we have this request API data function in onCreate view. So basically, whenever we open up our application, we're going to request a new data. But now we want to change that, and instead of requesting a new data every time, we want to read our database every time. And only if our database is empty, then we're going to call this request API data and request a new data. So from here, I'm going to remove this request API data call, and I'm going to basically create a new function named read database, and we're going to create this function. So Alt plus enter and create function. Okay, so this function will have no parameters, and from here we're going to call our main view model, and we're going to observe this read recipes, which is actually a live data of a list of recipes entity. So let's observe that. Here view lifecycle owner, and I'm going to name this database. Okay, so here I'm going to say if our database is not empty. So if our database is not empty, then we want to call our adapter, so m adapter dot set data, and here I'm going to pass a database, and I'm going to get the first position in our database, or the first row, so type 0 dot food recipe. Okay, so if our database is not empty, then basically we want to read from our database. So basically, if our database is not empty, that means that we already have some data and we want to display that data in our recycler view. And down below I'm going to call hide shimmer effect, because we have actually populated our recycler view, so we don't need this shimmer effect anymore. And in else block, we're going to basically request a new data, so request API data. Okay, so this is how our function should look like for now, but we might modify that in the future as well. So this function will be called from our onCreate view whenever our application starts, and it will check if our database is not empty, and if it is not, then we're going to read from our database, and if our database is empty, then we're going to request a new data. So we're going to test this out. So let me just add one log here, so log.d. I'm going to write here recipes fragment, and the message will be request API data called. Okay, and I'm going to copy this line of code and add inside this read database as well, but inside this if block. And I'm going to replace this with read database called. And now we're going to test this out. So as you can see, when I open up our application, so this application already have data in the database, because I have opened this application many times. So now when we run this application, we should be able to read the database, and we are not going to request a new API data, because we already have a data in our database. So I'm going to copy this tag here and open up a logcat. And here I'm going to run this app again, so we can see what log should be triggered now. Okay, and as you can see, here it says read database called, and that means basically that this read database was called, but this function request API data was not called. So that means that we have read from our database, and we didn't need to actually request a new API data, as you can see here. But now when we delete this application from our device, and when we run that again, you will see which log will be created now. So now you can see that the first request API data was called because our database was not empty. And when our database was called, we have cached our data to the database. And then this observer from a read database function was called again because it recognized that the new data was added to a database. So don't worry about it, we're going to handle that in the future as well. And for now you saw that everything here works fine, and I just want to create another function here. So first let me move this setup recycler view function on the top. So I'm going to select everything and click Ctrl X to cut that, and I'm going to paste that here on the top. And down below I'm going to create one more function, and I'm going to name this function load data from cache, and here I'm going to call a main view model dot read recipes, and I'm going to observe this one more time. So view lifecycle owner, and here basically I'm going to check if this database, so I'm going to name this database. So if database is not empty, then I want to call this adapter, and I want to set data to this database 0.food recipe. So we're going to call this load data from cache function inside our request API data inside this network result error block. So for example, when we run our API get request, and if we receive some error from our network, then we want to show to our user the previous state of our food recipes. So if our user receives some error, we're going to load the previous data from the cache, and that way our user will not suffer with empty recycler view. So there is one more thing which I want to do. So as you can see here, this read recipes live data is not actually a suspend function or anything. So now from here, from those observers, I'm going to call a lifecycle scope, and I'm going to launch Kotlin coroutine, and inside this coroutine I'm going to call those observers, and I'm going to do the same thing for our read recipes function as well. So I'm going to cut all of that, call a lifecycle scope to launch a coroutine, and inside I want to call this observer, okay? And now everything looks just fine. So we can run our app again and we can check what will actually happen. So now you can see that read database was called, and that is because we already have our data in the database and we don't need to request a new data. So new data will be requested when there is no any data in our database, and when we explicitly request a new data, and we're going to explicitly request a new data inside the new bottom sheet where we're going to choose our diets and meals and so on. And for that we need to first create a bottom sheet, but we're going to do that in some of the next videos. So that will be all for now. Hello there and welcome back. So in the previous video we have modified our recipes fragment a little bit. So from now on we are calling this read database function instead of request API data directly from this onCreateView method. And for now we're requesting a new API data when our database is empty. So let's run the app and let's see how it works. Okay, so when we open up this logcat, you will see that our read database function is called only and not our request API data. But there is one little issue. So for example, when we actually remove this application from our device and when we run that application again, you will see that both of those functions will run. So first one, request API data is called, and then read database is called. So how can this happen? Well, let's inspect the actual code. So when our application first runs, then our database is empty and this function is triggered, and after that this request API data is triggered, but not this block of code, okay? And only when we request a new API data, we are actually populating our database with the new data, and then this observer is called once again, and then that second time this first block is actually called, and that's how we can see this read database called after our request API data. And there is a way of calling this observer only once when we call our read database function, and for that I need to create a new extension function. So inside this util package I'm going to create a new Kotlin class or file. So this will be just a file, and I'm going to name this my extension functions. Okay, press enter. Okay, so here I'm going to paste one function. Okay, and basically this is an extension function for live data, and this extension function will basically observe this live data object only once and not every time. So here from our recipes fragment, now I'm going to call this new extension function. So inside this read database function I want to call observe once. Okay, and that's the exact extension function which we have already created. So now, for example, when we delete this application again, okay, so let's delete that. Okay, so now when we run this app for the first time, we are not going to see those two logs. Instead, we're going to see only one log. So request API data is called first, and then our read database was not called anymore, okay? So this observer from this read database function will be called only when this function is called, okay? And that's the exact behavior which we want to implement inside our application. So we have created this my extension function Kotlin file, and for now we only have this one extension function which we're going to use inside our project. Hello there and welcome back. So in the previous video we have created one extension function for our live data. So this function is named observe once, and we have added that function on our read recipes live data here. So the next thing which I want to show you is the actual database inspector tool. So this new database inspector tool was released from Android Studio version 4.1, and let me open that here. So you can see that right there, or you can access this database inspector from this menu on the top. So you go View, then Tool Windows, then a Database Inspector, okay? So basically that's the same thing. So in order to run this Database Inspector, you need to have your API level 26 or higher on your Android device. And for example, let me just run the app so we can actually see. And when you run the app, you will see that from here you can select your actual emulator and this actual package. So here we're going to see the name of our database, which is a recipes database, and we're going to see two tables. So this one is default table, so don't worry about that. And the second one is our actual recipes table. And in our case, this table has two columns, one ID, which is a primary key, and the second one a food recipe. And when we double click on this table, it will open up. So here we can see the actual ID, which is always 0, and we have our food recipe. So here, as you can see, the actual data which is stored in our database is in a format of a JSON, because we have used the library called the JSON to actually convert our food recipe object into this JSON, which is actually a string. And here we can see all the actual data which we have received from our API. So basically, when we receive a new data from API, we're going to store all of that inside this database, and we can even copy this to clipboard. So here you have option to refresh the table, but as you already know, our table will have only one row, and that row will be replaced with the new data every time we request a new data from our API. There is option here also to check this live update, so you can inspect your database live. So when we check that, then whenever we make some changes to our database from our application, that new change will appear here immediately. Also, from here we can select our DAO interface. So for example, this one, and here you will see this special icon on the left side. So that means that this query from our DAO can be run inside the database inspector. So if we press that, you will see that a new tab here will appear with the same exact query from our recipes DAO. And here we can write our own custom query. So for here, for example, I can type the ascending order instead, but since we have only one ID, it will have no change, but still you can just write your custom queries here and click run, and they will run and you can see the result. So you can double check your queries if they are actually working, and you can access this new query tab from this icon here as well. So you can just click here and then this new query tab will appear, and from here you can select the actual database, and then you can write some queries here. So I just wanted to show you this database inspector tool, and later when we start working with our database even more, we're going to use this database inspector to check the actual result of our API response here. And for now, you just need to know about this tool, so it's very handy, and you can also check your queries here to see if they are actually working. So that will be all for this video. Hello there and welcome back. So in this video I'm going to show you how to display error placeholder image into your image view when there is some error. So for example, when there is no an internet connection here, let me just disable this internet connection on this emulator device, and let's run the app again so you can actually see what this is all about. So as you can see, when we try to scroll down and fetch some images that are not actually cached, as you can see here, so those images are not shown because those images were not cached by the Coil image loading library, and because there is no internet connection we cannot fetch them again. And in that case we want to display some placeholder image which will represent that there is some error with those images, okay? And for that purposes we're going to use our Coil image loading library, and basically with just one line of code add that placeholder image. So before we actually open our binding adapter, we need to add one vector file here. So I have already prepared that vector asset, and I'm going to load that from my PC. Okay, so here it is, error placeholder SVG file. I have created that by myself, and you can access this same file from my GitHub repository as well. So click OK, and the name is fine, and this is how it looks like, okay? So I'm going to press next and finish. So now that we have added this placeholder into our drawable directory, I can open up this binding adapter, and here inside this load image from URL function, I need to add one more line of code here, error, and here I need to specify the actual name of this placeholder. So r.drawable error placeholder. Okay, so now when I run the app, you will see that all of those images that were blank a previous time, then they will show now this error placeholder. Okay, alright, so let's scroll down below, and now you can see that all images which are actually not loaded, and that's because we don't actually have internet connection, then those image views will show this error placeholder. And it looks very nice. So only those images that were cached properly when there was an internet connection, then they will display, but those images that were not cached correctly, then they will display this error placeholder. Okay, so now our application looks even better. Hello there and welcome back. So in the previous videos we have modified our recipes fragment, and from now on we are reading from our database first, and only when we need new data from our API we are going to request that. So far we have also created our binding adapters for recipes row layout. So this is the actual layout for which we have created this recipes row binding. And in this video we need to create another class for binding adapters, and this time for our fragment recipes. So this fragment recipes layout contains this recycler view, then the floating action button, and those two views on the bottom. So we have image view and a text view. And by default those two views are hidden. So here we can set their visibility to visible for now, so we can actually check them out. So as you can see we have one image view and a text view. So the image view should stay the same, and the text down below should be changed, depends on our API response. And for that purpose we need to create a binding adapter for this layout. So again I'm going to set their visibility to invisible. So that's their default value. Okay, so first thing we need to do, we need to convert this layout to a data binding layout. So let's get into the XML code, and here place your mouse on this root layout and press Alt plus Enter. And here you're going to see this option that says convert to data binding layout. So click that, and here we have converted our layout to a data binding layout. So we should have one variable here, so let's add this variable attribute. And the name of this variable should be main view model, and the type of this attribute should be com.example.foodie, then view models, and then we should choose this main view model. So the next thing we need to do, we need to go to our recipes fragment, and we should bind our main view model with the exact variable which we have created. So here on the top I'm going to create one or actually two variables. So private var binding, and the type of this variable should be fragment recipes binding. So this class is automatically created for our fragment recipes layout when we have converted our layout. So just click that, and we're going to set its initial value to be null. And down below we're going to create another one, and this time we're going to choose a vol, then binding, and then I'm going to use a getter. And here I'm going to call this underscore binding, okay? So after that I'm going to delete this mview, and here I'm going to replace that with underscore binding, and here I'm going to replace this inflator with fragment recipes binding, okay, so this one. And instead of inflating this layout we can just pass this inflator, okay. And down below I'm going to call this binding without the underscore. So here I need to set a lifecycle owner, and the lifecycle owner is actual fragment, so type this. Okay, so we have a warning here, and I'm going to add a double bang operator right here. Okay, so here. So if you're wondering why we need to specify this lifecycle owner when we are binding our data with our XML layout, well, the reason is because in our fragment recipes layout we're going to use live data variables or live data objects, and that's why we need to specify this lifecycle owner. And down below I'm going to call this binding to actually bind this variable named main view model with our view model. So here I'm going to type main view model. Okay, so this is our actual main view model, which we have initialized inside this onCreate method, and the onCreate method is called before onCreate view, so that's all perfect. And here, instead of this mView, I'm going to return a binding.root. Okay, and I'm going to replace all those mView with binding. Okay, so just replace everything from here and down below here as well with binding. So at the end of this recipes fragment, I need to override a method on destroy, so this one, and here I need to set this binding to null. So basically with this we are going to avoid we're going to avoid the memory leaks. So whenever our recipes fragment is destroyed, this binding will be set to null. So that's perfect. And from our recipes fragment, we basically did everything we need to. So we have binded our main view model variable with the instance of our main view model from a recipes fragment. And also we have specified this lifecycle owner. And of course our fragment recipes layout looks perfect. So the next thing, we need to create a custom binding adapter for our recipes fragment. So inside this binding adapters package, I need to create a new class. And this class should be named recipes binding. So inside this class I need to add a companion object like we have in our other recipes row binding here. And we need to add two functions here. So the first function will be used for our image view here, and the second function will be used for our text view here. So I'm going to name this function error image view visibility. And here I'm going to add three parameters. So the first parameter is the actual view on which we're going to use this custom binding adapter, and that is our image view. So the second parameter is our API response, and the type of this variable should be network result and food recipe inside. So I'm going to add this question mark because this is actually a nullable type. And the third one will be a database. And the type of this database should be a list of recipes entity. Okay, so let me just set this capital letter. Okay. And I'm going to annotate this function with two annotations. So the first one is a binding adapter, of course. And here we need to specify this time two different attributes, because we have two variables here which we need to use from our fragment recipes. And that's why we need to specify now two attributes. So the first attribute will be used for our API response, and the second one for our database. So we need to follow up that order. And this one should say read API response, and the second one read database. And as a third parameter, I need to set require all to true. So that means that we want to make our compiler display a warning or an error if we specify only one attribute. We will need to specify all of those two attributes, read API response and read database. So that's the only way to actually use this binding adapter, because we're going to need those two variables. And the second one is JVM static. Okay, so inside this function we're going to add if block, and we're going to say if API response is network result dot error, and we're going to add here and two ampersand symbols. So and database dot is null or empty. Okay, so if our API response is actually network result error, and if our database is null or empty, so if those two are true, then we want to set our image view visibility to visible. Okay, so view dot visible. So our error image view will basically be visible only when our API response is error and our database is null or empty. And that is when our recycler view is actually empty, because if we already have some data in our database, we want to display that data and not show this image view, of course. Okay, so next else if. So if API response is network result dot loading, then this image view visibility should be invisible. And if our API response is network result dot success, then this image view visibility should be invisible as well. So basically our image view should be visible only if our API response returns an error and if our database is null or empty. Otherwise, our image view will be invisible. So this is the first binding adapter which we have created, and we're going to create one more. But before that, let me just open this fragment recipes, and we are going to satisfy those two values. So let me open that, and here on our image view, I need to specify this read API response, and here I'm going to use main view model dot recipes response, and I need to specify also read database, and for the read database I need to specify main view model dot read recipes. And if I open this main view model, so let me just open that, you will see that this read recipes live data is actually for our room database, and as you can see we have specified that variable correctly, and our recipes response is used for our retrofit library. So recipes response. So we are using those two values basically to decide what we are going to do with our image view and the text view visibility. And now we need to create another one. So next let's create one more function. So this time function should be named error text view visibility. So this function will have 3 parameters as well, but the first parameter will be text view, and the last two I'm going to copy from the first function. Okay, and here I'm going to also copy this function body and paste that here, but instead of this image view I'm going to use a text view, and plus we need to set our text here. Okay, so that's the main difference between this function and the first function. So inside this first if block I'm going to remove that for now. Okay, so inside this if block we need to set our text view visibility, so view.visible, and also we need to set the text view text, so text equal to API response dot message to string, and of course we need to annotate this function with binding adapter. So this binding adapter should have 2 attributes like we did in the first function, and this time I'm going to call this first read API response number 2, and the second one read database number 2, and require all to true. Okay, and now let's add the JVM static annotation, and inside our fragment recipes this time I'm going to call this read API response number 2 and read database number 2, and just pass those 2 values like we did in the previous example on the top. So now let's run our app and let's see how will that work. Okay, so we have received an error and we're going to fix that. So basically what we need to do, we need to specify that those 2 fields are actually nullable, and I'm going to remove this question mark inside, and I'm going to set that outside. So here and here, so I can remove that. Okay, and now let's run the app and let's see if everything is gonna work fine. Okay, so as you can see our application is running, and now we're going to test our binding adapters, and we're going to disable internet connection, and we're going to remove our application, and we're going to install that again on our Android emulator. So here I'm going to remove that. Okay, and now let's run our app again, and this time there is no internet connection, and as you can see we have received this toast message, and our image view and text view are visible, and our text view is showing the appropriate text here, so no internet connection, and that's the exact message which we have received from our main view model or from our API response. And for example, when we turn on the internet and when we run the app again, you will see that now those 2 views will be invisible. And as you can see, everything works perfectly fine. So our recipes binding is working perfectly fine. And that will be all for this video. Hello there and welcome back. So in this video I will briefly introduce you with Data Store library. Jetpack Data Store is a data storage solution that allows you to store key and value pairs or typed objects with protocol buffers. Data Store uses Kotlin coroutines and flow to store the data. In short, it's a new data storage solution which is a replacement of all the shared preferences, and shared preferences has some drawbacks, like it provides a synchronous API and it's not a main thread safe, where data store is safe to use in a UI thread because it uses dispatcher's IO under the hood, and also data store is safe from runtime exceptions as well. Data store provides two different types of implementations to store the data. The first one is a preference data store. This uses key and value pairs to store the data, but it does not provide type safety. And the other one is a proto data store. It stores the data as a custom type with a specified schema using protocol buffers, but in this course we will focus only on preferences data store, and if you want to learn more about proto data store, you can watch my video tutorial on my YouTube channel. So for using a data store library, you will need to add a proper dependency, and at the time of creating this course I'm using Alpha 02 version, but that may change in the future. So that was just a short introduction to Jetpack's data store, and from some of the next videos we will start implementing data store preferences in our project, and you will see how it's done. Hello there and welcome back. So with this video we're going to start working on our bottom sheet. So this is our application design from Adobe XD, and this design project is available for you to download in this course as well. So this is how our bottom sheet should look like. So here we're going to have two options, meal type and diet type. So here from meal types, a user can choose various different meals from our Spoonacular API, and down below for diet as well. So here a user would have option to select only one of those meal types and only one from those diet types, and those are chips inside. So you will have an option to choose only one from each one of those categories, and I'm going to set the default recipes to be main course vegan or main course gluten-free, for example. I'm going to see that. So when the user first time installs the app, and when this bottom sheet is open for the first time, then this main course and gluten-free will be checked. So those are the default values which we're going to use to fetch our API data. And later user can choose one of those different meal types and diet types. And basically with this apply button, we're going to get back to our recipes fragment and apply those changes. So in our case, instead of having those two rows of chips, I'm going to have only one row for each category, and that is because we have a lot of those types, and they will not fit in only two rows. So that's why I'm going to add only one row of those chips, and we can scroll them horizontally to check out more. So basically, what is this bottom sheet? So this bottom sheet is basically a fragment, but instead of inheriting from a fragment class, we're going to inherit from a bottom sheet dialog fragment class. Okay, so you will see when we start actually creating one. So basically, whenever we click on this floating action button, this bottom sheet will appear from the bottom. And from there we will be able to select one meal type and one diet type, and when we press apply, then we're going to get back to this recipes screen, and from there our application will automatically fetch a new data from our API. So that's how it's gonna work, and in the next video we're going to start designing this bottom sheet. Hello there and welcome back. So in this video we're going to create and design one bottom sheet. So first we need to think where we are going to place our bottom sheet, and I'm going to place that inside the UI package, then fragments, then recipes. So I'm going to place this bottom sheet inside this recipes package, because this bottom sheet will open on top of this recipes fragment, and here inside I'm going to create a new package named bottom sheet. Okay, and inside I'm going to create a new fragment. So down below search for fragment, then I'm going to select fragment blank, and here I'm going to type the name of this fragment. So I'm going to say recipes bottom sheet. So press OK and finish. So I'm going to remove all unnecessary code from this recipes bottom sheet. So I don't need that or this companion object. Okay. So instead of inheriting from this fragment class, I'm going to use bottom sheet dialog fragment. Okay. So this one. And now this will represent a bottom sheet. So in this exact video, we're going to design our layout for a bottom sheet. So here it is, fragment recipes bottom sheet. And I can rename this layout file to say just recipes bottom sheet. So let me go to this resource, then layout, and here right click, then refactor, rename. And I'm going to remove this fragment. So just the recipes bottom sheet, click refactor. Okay, perfect. So now we can open that bottom sheet, and here we can start designing. So first I'm going to replace this frame layout with a constraint layout. Okay. So for now I'm going to set layout height to be match parent, but we're going to change that. So the next thing, I want to add a background color here, and I'm going to set that to white for now, but we might change this style in the future. So let me remove that, and okay, so from here I'm going to remove everything, and I'm going to add all elements by myself. So here let's add one text view. Okay, I'm going to constrain this text view on the left and on the top. So the margins on the left and the top should be 24. Okay, so this text should say meal type. And I'm going to press Alt plus Enter and extract this string into our strings XML. So meal type, okay. Text size should be 18 SP. Text style should be bold. And text color should be dark. Okay, alright. So below this text view, I need to add a horizontal scroll view. And inside that horizontal scroll view, I need to add all my chips. So let's search for a horizontal scroll view. Okay, there it is. So I'm going to set the layout height to be 60 dp for now, so we can actually see that here on the screen. So I'm going to connect left, right, and the top constraint to this text view. So the top constraint should be 12, and the left and right should be 16. Okay, so I'm going to set the ID of this horizontal scroll view. So scroll view meal type. Okay, that's perfect. And I'm going to set one attribute named scroll bars to none. So basically those scroll bars will not be visible, and that's why I have added this none. So for now the height of this horizontal scroll view will be 60 dp, but later we're going to change that to wrap content. So as you can see, inside our scroll view we have a linear layout, and we're going to change its orientation to horizontal. And also I'm going to add the end tag of this layout, so we can actually add new items inside. Okay. So here I'm going to search for a chip group, okay? So this chip group will contain all our chips. So I'm going to drag and drop that inside this linear layout. Okay. So I'm going to add the ID to this chip group. So meal type chip group. And I can change this horizontal scroll view to say, so press Shift plus F6, and it could say meal type scroll view instead. Okay, I'm going to refactor that. Alright. So next, inside this chip group, I want to add the attribute named selection required to true. So if you press Ctrl plus Q on this attribute, you will see its actual meaning. So here it says whether we prevent all child chips from being deselected. It's false by default. So basically with this attribute true means that you will not be able to deselect your chips inside this chip group. So one chip must be selected every time, and you cannot select one chip and then deselect everything. So one chip will be selected all the time. And down below I'm going to later write which chip will be selected by default. And now I'm going to add one more single line to true. So all our chips inside this chip group will be basically stored in one line. So here if we press Ctrl+Q, it will say that constrains the chips in this group to a single horizontal line. By default this is false and chips in this group will reflow to multiple lines. But if you set this to true, you will usually want to wrap this chip group in a horizontal scroll view, which is the exact thing which we already did. Next I'm going to add one more attribute, single selection to true. So if we press Ctrl+Q on this attribute, it will say whether only a single chip in this group is allowed to be checked at any time. By default this is false, and the multiple chips in this group are allowed to be checked at once. But with this attribute set to true, then we're going to be able to select only one chip and not multiple chips in this one chip group. So now it is time for us to add each one of those meal type chips inside. So here I'm going to search for chip, but before that I'm going to open a web browser and check again this Spoonacular API documentation, so we can see all the meal types which we can use for our API. So once you open this Spoonacular website, you go to docs, then a full documentation, and from here we're going to search down and see this diet attribute or parameter, and then just open this list of supported diets, and down below for the type open this list of supported meal types. Okay, so let's first check this meal type. So as you can see, this is the full list of supported meal types for this API, and we're going to basically copy the names of those meal types in our chip group. So the first one is main course, so I'm going to add a new chip here. So let's search for a chip and let's add that chip inside this chip group. Okay, so the actual ID of this chip should be main course chip. Okay, and down below we're going to add one more attribute, text. So this text will say main course, and we're going to press Alt plus Enter to extract this string. So just click OK, and here it is. So this is how our chip looks like. And of course we can now set this horizontal scroll view height to wrap content. So now it will increase its height depending on the content inside. And next I can just copy and paste this chip down below, and I can just change the name and the ID. So here we have next side dish, and here I can type just side dish. Just press Alt plus Enter and click this one. Okay. So next we have dessert and appetizer. So just copy and paste down below. So dessert. And this is how our meal type chip group should look like. So now when we scroll up, we need to add one more attribute on our chip group here. So here I need to select checked chip, and I need to enter the ID of the chip which will be checked by default, and that is our main course chip. So now this chip will be checked by default, but now you cannot see. So basically in this meal type chip group, this main course chip will be checked chip by default, and here you cannot see that checked state, but you're going to see that later. And also in the next video we're going to create a custom style for our chips, so you will see. And the next thing, we need to create a new chip group down below for diet types. So first let me just basically copy and paste this first text view, okay, and I'm going to change its ID, so I have forgot to do that. So Shift plus F6, so we can refactor the name, and I can type here meal type txt, okay, refactor, and now I can copy this text view down below. So here, and I can rename this ID to diet type txt, and I can remove constraints for now. And I can just set the different text here, so diet type, okay, and I'm going to place this text view down below. So the left margin should be connected to a parent, and the top margin should be connected to this horizontal scroll view. Okay, so the left margin should be 24 as in our first text view, and the top one should be 12. Okay, like that. And now down below I need to add one more horizontal scroll view and one more chip group. So let me just try and copy this horizontal scroll view from the top, and I can just change its values. Okay, so let me see. Below this text view. And okay, so don't worry about those warnings, we're going to change that. Okay, so now I can change this second horizontal scroll view ID to diet type scroll view, and I can remove its constraints here, so those 3 constraints. Okay, and now from here I can just select this whole and place that here. Okay, so I can just now change those constraints. So here I'm going to set the constraint top to bottom off, and I'm going to set here diet type txt. Okay, like that. And of course left and right should be constrained to a parent of 16, and the top constraint should be 12 as before. So now the only thing there is for us to actually change the IDs of those chips and this chip group. So I'm going to rename this chip group to diet type chip group. Okay. And now we need to basically write different text for our chips. So let me open this official documentation, and let's see all the diets which we can have in our API. So I'm not going to add all of those, so I'm going to skip this lacto-vegetarian and ovo-vegetarian for now, because we only have this one single vegetarian. So I think that's fine. So let's change the IDs and the text of our chips. So first we have gluten-free, then ketogenic. So here let's rename this to gluten-free, and the name here as well, so gluten-free. Press Alt plus Enter. Okay. Next one here is ketogenic, and let's change this text here to ketogenic as well. So Alt plus Enter. Okay. Okay, so we have added all our diet types, and we can remove the rest of those chips down below because we don't need them. Okay, and now we have removed all warnings we have in our layout. And of course I can just add this string as well, so Alt plus Enter. Okay, so this is how our layout should look like for now, and this is layout for our bottom sheet, of course. Okay, so basically we have created our bottom sheet, and there is only one view which we need to add, and that is a button. So let's add here a new button. Okay, let's connect the left constraint here, right constraint to a parent as well, top constraint to this horizontal scroll view, and the bottom constraint to a parent as well. So now I'm going to set this overall root layout height to be wrap content. Okay, and now I can change this margins to 24 on each and every side. So 24 here, 24 here, and here. And now I can set this button width to be match parent. So here match parent. Okay. And I can set its height to be 60 dp, so a little bit bigger. I can change this text to apply. I can set caps, text all caps to false. And of course I can change this ID to apply button. And for now I think that that will be all. So let's just add this text to our string resource. Okay. Okay, so one more thing, and we have forgot to edit one attribute on our second chip group. So as you can see on our second chip group, we need to change this attribute checked chip, and we need to change this from main course to gluten-free chip, for example. So now selected chips by default will be this main course and gluten-free, and those are the recipes which are going to be shown in our application the first time a user installs this application, and of course later we will be able to change that. And this is how our bottom sheet should look like for now. So we might change that in the future, but for now it looks exactly as we wanted. So that will be all for this video, and in the next video we're going to continue working on our bottom sheet. Hello there and welcome back. So in the previous video we have designed our bottom sheet, and now in this video we want to create all the necessary logic needed for us to navigate from our recipes fragment to this recipes bottom sheet. And we will be able to navigate to our bottom sheet by clicking on this floating action button. So before all of that, we need to open up our nav graph or navigation graph. So inside this resource directory and inside this navigation directory, we need to open up our navigation graph, and here we need to add a new destination. So in this case, I'm going to select this icon and I'm going to find this recipes bottom sheet. So just select that. And I'm going to place that, for example, right here. So now I need to connect this recipes fragment with this recipes bottom sheet. So I'm going to just connect those two, and this recipes bottom sheet with recipes fragment as well. Okay, so something like that. And when I open this XML, we're going to see this recipes bottom sheet, and we're going to see a new action here. So action recipes bottom sheet to recipes fragment, and this action recipes fragment to recipes bottom sheet. So after we have added a new destination to our navigation graph, we can open up this recipes fragment, and here we're going to add the on-click listener for our floating action button. But before that, I want to change this ID of this floating action button. So I'm going to rename this into something like recipes underscore fab. Okay, so this looks even better. And now from our recipes fragment, I'm going to call binding dot recipes fab dot set on click listener, and here I'm going to call find nav controller dot navigate, and here I'm going to pass the actual ID, so r.id dot action recipes fragment to recipes bottom sheet, so this one. And now let's run the app and see if this will open up our bottom sheet. Okay, so let's select our floating action button, and you will see that a new fragment appeared instead of our bottom sheet. So how is that possible? Well, you need to be very careful. So in this navigation graph file, you need to replace this fragment tag with dialog tag. And now let's run our application, and now our bottom sheet should appear perfectly fine. So let's click on that, and as you can see, it works perfectly fine. As you can see, when we press on one of those chips, nothing happens, and that is because we haven't specified yet the actual style of those chips, and we're going to customize the actual style of those chips in the next video. So here you can just close this bottom sheet just by pressing somewhere on the screen. And as you can see, it works perfectly fine. So that will be all for this video. Hello there and welcome back. So in this video we're going to stylize our chips. So before we actually start creating a custom style, I want to introduce you with the actual chips, and they are actually types. So chips are basically compact components that display discrete information. They are flexible enough to be used for entering information, filtering the content, selection, and triggering actions. So chips are most of the time used in a group. And from a design perspective, there are four categories or four main types of chips. So the first one is input chip, and it represents discrete information as input to a field. And here on this image you can see the actual look of input chips. Then we have choice chips. Choice chip represent a single choice selection in a group of two or more chips. And this is how it can look like. Then we have filter chips. They represent a multiple choice filter in a group of two or more chips, and they always have this check mark icon on the left side. And finally we have action chips, and they are used to trigger a given action. They also contain icon and a text label as well. So in our case we're going to use filter chips, which have this checkmark icon in front of the text, and you will see. So for now what we need to do, we need to open our values directory here, and we need to open up styles XML. So here we need to define a custom style for our chips. So we need to add a style element here, and the name of this style should be custom chip style. So as a parent we're going to use widget.material components chip filter. So as you can see, we have different kind of chips here. So we have action, choice, entry, and filter. So input chip is actually an entry chip, so that's basically the same. And here we're going to select this filter chip as a parent of our custom chip style. And inside this style we're going to specify different attributes. So the first item here should be named chip background color. And for this item we're going to specify our own XML file. So before we actually specify that, we need to create one. So inside this resource directory we need to create another resource, Android resource directory. And from here, from this resource type, we need to find the color, so this one, and click OK. And inside this directory we need to create a new XML file, so new color resource file. And the name of this file should be chip underscore background underscore color. Click OK. So the root element here will be a selector. So here we need to specify two items. And the first item will be basically a color for our chip background when our chip is checked or selected. And the second item will be for our chip background color when our chip is not selected. So before we actually add those items, we need to add the new colors to our colors XML file. So let me just open that. And down below I'm going to create one comment here. So custom chip style. And here I'm going to specify a new color. So the name of this color should be checked chip background color. So the actual color which we're going to add here is primary color here, but we're going to add 20% of this color primary, okay? So we need to add this hashtag, then 20, and the first two values represent the actual opacity or the alpha values. And then we can just paste the actual color code. So this color is basically a 20% opacity of our primary color. Okay, so the next color will be named just chip background color. So the first one is for the checked state, and this one will be for default state. And from here I'm going to just link the color light gray. Okay, so now from our chip background color XML file we can add the new items. So let's add item, and for the color I'm going to select color slash checked chip background color, and here I'm going to specify attribute named state checked, and I'm going to set that to true. So basically this checked chip background color will be used for our chip when it's in a checked state, and as you can see this is the actual color, so 20% opacity of our color primary. And I'm going to just copy this line of code with Ctrl D, and here I'm going to set this checked state to false, and from here I'm going to select just chip background color. Okay, so from the colors here I just want to rename this, so Shift plus F6, and I'm going to say checked instead of check, so checked chip background color. Click refactor, and now that name should be changed here as well. So now that we have created this XML file for our chip background color, now we can get and write here inside our new custom chip style. So here I'm going to just add this @ symbol, then color, then chip background color, so this one. So this is the actual XML resource which we have created. So now we have specified the actual background color of our chip, and now it is time for us to customize the text color of our chip. So here I'm going to add a new item, and the name should be text color. So Android text color. And here again, before I specify anything, I need to create a new custom XML file inside this color directory as well. So here I'm going to create a new color resource file, and the name of this file should be chip underscore text underscore color. Okay, press OK. And again, this file will have two items inside as well. But before I specify those items, I need to add some more colors inside this colors XML. So the name of this color should be, let me see, checked chip text color. And the color of our text when the chip is selected will be actually color primary. So color primary. Okay, and finally we need to create another color item here, so chip text color, and this color will be used when our chip is in default state. So I'm going to reference here color dark gray. So now inside this chip text color I can add 2 new items. So item, and here we're going to specify those 2 colors. So the first color was checked chip text color, and here the state checked is true. So we have specified the one color for our chip in the state when it is checked. So when our chip is checked, then the text of our chip will be this purple color, or our color primary. And let's add a new item here, and let's specify the second color which we have created. So chip text color. Okay, and the state checked should be to false. And now inside our styles XML, we need to specify this new XML file. So chip text color. Okay. And also we need to specify icon color. So as you already know, our filter chip contains the icon as well, and that icon is the actual checkmark icon. So for that icon we're going to select the same style which we have already applied to our text. So here I'm going to specify a new item named checked icon tint, and here I'm going to specify the same file, so chip text color. Okay, and after we have created all of those colors and styles, now we need to apply this custom chip style to all our chips. So now inside our recipes bottom sheet we need to open our XML. Okay, so here inside the recipes bottom sheet we need to specify our custom style on each and every chip we have inside our layout. So here let's add a new attribute named style, and let's just get the reference of this custom chip style. And I'm going to copy this line of code and basically paste inside every chip inside this layout. Okay, so now we have added this style to all our chips, and we can run the app and see how will that look like. So as you can see here in our layout, so if you don't see this change immediately, then I highly suggest you to run the app or just rebuild the project. And as you can see, those 2 chips here in those 2 categories, so main course and gluten-free, are actually the default selected chips in our chip group. So as you can see in this first chip group, we have attribute here that says checked chip, and it's pointing to our main course chip. So that means that this main course chip is selected by default. And inside this second group we have specified that attribute as well. So you can see that here this gluten-free chip is selected by default. And here you can see the actual style of those filter chips. So they have this checkmark icon on the left side and the text, of course. So let's run the app and let's see how will our style actually look like. Okay, so as you can see it looks very nice. And as you can see in each and every group here we can select only one chip and no more. And also we cannot deselect and have 0 selected chips, so because we have specified that selection is required right there. And as you can see here as well, we can only have 1 selected chips in each of those 2 groups. And of course default selection will be on our main course and on our gluten-free. So now I'm going to open up this recipes view model, and I'm going to replace those values. So here I'm going to write main course, and here I'm going to write gluten-free. So those are the default values for our get request. And for now we have stylized our chips, and it looks very nice. So that will be all for this video. Hello there and welcome back. So in the previous video we have designed the actual style of our chips, and it all looks very nice. So in this video we're going to create a data store repository where we're going to persist our data. So let me just open this app in this Android emulator. So as you can see, when we navigate to this bottom view, or bottom sheet, then whenever user selects some of those choices from our meal and diet type, and when a user press apply, we want to save those chip values, and we want to persist them using data store preferences. So basically, whenever user selects, for example, main course and vegan, and when a user clicks apply, we want to save those choices, so main course and vegan. So when user close this bottom sheet and navigate back to this bottom sheet, then we're going to read those same values which we have saved using data store preferences, and we want to apply that to our chips so they can be selected, okay? So that's how basically we're going to save those users selection. And inside our recipes bottom sheet, we're going to basically read and save those values, and you will see later when we actually start doing that. But before that, we're going to create our data store repository. And before we actually create that repository, I want to open up our constants class, and here I want to add some more constants. So down below I'm going to add one comment here saying bottom sheet and preferences. Okay, so here I'm going to create a couple of constants. So the first one will be named default meal type. So default meal type will be main course, as I already said. Next, the default diet type will be gluten free, and we're going to use those two constants to replace the actual values inside our recipes view model. So we can just copy this name, and here inside this recipes view model I'm going to replace those hard-coded values with those constants. So first I'm going to delete that and paste the name of this default meal type. So press Alt and Enter so we can import that, and this second one as well, so Ctrl C to copy that. Now let's remove that and replace with this constant, so Alt plus Enter. Okay, and we can create also one constant for this number. So let me just add this on the top, so default recipes number, and I'm going to set that to 50. Okay, replace that, Alt plus Enter. Okay, so for those true I'm not going to create a constant, only for those three, and down below I need to create a few more constants, but I'm going to do that a little bit later. So we're going to get back to our constants class later. And now we need to open this data package. Then inside this data package we're going to create a new class, and the name of this class should be data store repository. Okay, so select class here, press Enter. So first, inside this data store repository I need to inject application context. So I'm going to use this inject annotation, then constructor keyword, and here I'm going to use annotation application context, then private vol context. Okay, so we're going to need this context for our data store. So the main difference between data store and shared preferences is that data store is running on a background thread and not on main thread, and plus with the data store it's a little bit different. So first we need to define our preferences keys. So I'm going to create here one private object named preferences or preference keys. Okay. So here we need to define all our keys which we're going to use for our data store preferences. So first let's create one variable named selected meal type, and here I'm going to use this preferences key. So here I need to specify the actual type of this value, and that type will be a string. Okay, and here inside I need to specify the actual name of that key. Okay. So as you can see here, I'm not defining this value immediately, I'm only defining the key. So here for the key, I'm going to say meal type. So under that key, inside this data store, I'm going to store a value of type string. And we're going to define how to store that value a little bit later, but for now we are just defining the actual keys, okay? So the key for this selected meal type will be just a meal type. So from our bottom sheet, as you can see here, we will basically save the name of our chip and the actual ID of that chip, okay? So we need to save the actual ID of the chip so we can actually apply the selection when we actually read that, so you will see. Now let's create next variable named selected meal type ID. So here again we're going to use the preferences keys, but this time for the type I'm going to add an integer. Okay, and here I'm going to write meal type ID. So for the meal type chip, we need to add two keys, or basically we need to store two values. The one, the actual text of this chip, and the second, the actual ID of that chip. Okay, so we're going to need to read that ID when we open this bottom sheet in order to read our data store preferences and apply that selection which we have saved. So down below I need to create two more preference keys for diet type. So selected diet type. So here preferences key, so string, and here I'm going to say diet type, and down below selected diet type ID. So this will be an integer because this is an ID of our selected chip, so you will see, and the diet type ID for the key name. So now what we can do, we can store those values inside our constants class as well. So I'm going to basically copy that meal type, and down below I'm going to add new constants for each one of those. So I'm going to name that preferences meal type. Okay, next one meal type ID. Okay, next one is diet type. Okay, next one is diet type ID, and here diet type ID. Okay, so now we're going to use those constants instead of those hard-coded values. So for the meal type, paste this preferences meal type. Okay, next for this meal type ID, just pass this constant, so copy and paste that, Alt plus enter. Next we have diet type. Okay, Alt plus enter, and finally our preferences type ID. Okay, so we have added all of those four, and it's now a lot easier to actually modify those values if we need that, so we can modify that just in one place. Okay, so now that we have created our preferences keys, we can proceed and create our data store. So I'm going to use a private vol data store. The type will be a data store, and here I'm going to pass this Android X data store preferences. And I'm going to import this Android X data store. Okay, Alt plus enter. And here I need to use this context to actually create a data store. And inside here I need to pass the name of this data store. So I'm going to create a new constant for that name. And here I'm going to write preferences name. And here I'm going to say foodie preferences. So this will be the name of our data store preference. And basically under that name, all other values will be stored. So here I'm going to write name, then preferences name. I'm going to import that. Okay. So down below I'm going to create one more data class. So here I'm going to write data class named meal and diet type. So this class will have four different fields. The first one, selected meal type of type string. Next one, selected meal type ID of a type integer. Next one, selected diet type of a type string, and finally selected diet type ID of a type integer. Okay, so those are the four fields which will be inside this meal and diet type class, and we're going to use this actual class to pass those four values, so you will see. So now inside this data store repository we need to create one function for actually saving those values. So I'm going to write here fun save meal and diet type, and this function will have four different parameters. So all those four values, so meal type of a type string, meal type ID of a type integer, diet type of a type string, diet type ID of a type integer, and that's it. So four of those fields. And inside this function I'm going to use this data store to actually save those values. So data store dot edit, and here I'm going to set the name to preferences. So this is basically an mutable preferences object, and inside these brackets I need to specify this preference key one by one. So I'm going to type preferences preference keys dot now selected meal type first. Okay, and here I'm going to specify meal type from the parameters. So basically here we're specifying the actual key name, and here is the value. So the value will be passed through this function, save meal and diet type, and from here we're basically just specifying this key. So this key will be associated with this specific value from our parameters. Okay, so before we continue, here we have a warning. So basically this edit is a suspend function, and that's why this data store is using Kotlin coroutines to run on a background thread. So we need to add a suspend keyword in front of this function, which is totally fine. So down below I need to associate those values from the parameters with those exact preferences keys which we have created. So preferences, here I'm going to write preferences keys. This is the object which we have created on the top. Then selected meal type ID, and here meal type ID, of course. Okay, so preferences keys, selected diet type, here just pass a diet type, and finally we have preferences keys, selected diet type ID, and here pass a diet type ID. Okay, so instead of meal I need to type diet here. So basically this function will take those values from its parameters for meal type ID, diet type, and diet type ID. So basically those are the values for our chips from bottom sheet, and we're going to store those values inside our data store preference using those specific keys which we have already specified. So I think that's pretty much self-explanatory. So we're basically saving our fields which we pass inside these function parameters, and we are saving them inside our data store preference using those keys. So the next thing is we need to create a way to actually read those values which we are storing, and for that I'm going to create a new variable. So I'm going to create new variable down below. So the name of this variable should be read meal and diet type. So the type of this variable should be a flow. So choose a Kotlin X coroutines.flow, so this one, and the type should be meal and diet type. So this is the exact class which we have created here, and basically when we are reading those values from our bottom sheet, we're going to use flow to pass this class meal and diet type, and this class will contain those 4 different fields for each one of those values. Okay, so here I'm going to use a data store object, and I'm going to set .data. So down below first I'm going to use one method or function called catch, and here I'm going to catch exception if there is one. So here I'm going to write exception, and I'm going to write here if exception is IO exception. Okay, then I want to emit empty preferences. Okay, so empty preferences. So if there is an exception, I'm going to basically emit empty preferences from this flow, and I'm going to add also else block here to just throw an exception. So throw exception which we have already specified. Okay, and down below I'm going to call one function named map. Okay, so I'm going to write here preferences. So basically inside this block I'm going to create 4 different variables for those 4 values, and then I'm going to create one meal and diet type object, and I want to emit that object using flow. So the type of this flow is a meal and diet type, so that means that we need to return that same object, and here we're going to create that object using those 4 different values. So first I'm going to create selected meal type variable here, and I'm going to use preferences to actually get the value, and here I'm going to type the actual key, so preferences key dot selected meal type. So I'm going to use Elvis operator here, so question mark and colon, and here I'm going to type main course. So what this line of code actually does, so as you can see here, we're basically storing some value inside this variable. So here basically we are selecting the value of this specific key, so selected meal type key, and if there is no any value saved already, then we're going to emit this main course. So if there is no any value inside our data store for this specific key, then we're going to return this main course, which is logical, of course. And down below I'm going to do the same thing for the rest of those 3 values. So next one is selected meal type ID. So here again preference keys dot selected meal type ID. Okay, and in this case if there is no any value, I'm going to return 0. Okay, So next I'm going to create 2 more. So I'm going to just copy those 2 here, and I'm going to change their name here. So diet here, and the diet here. And here, of course, diet and diet. And here I'm going to change to gluten-free. And finally, after we have grabbed that data from our data store, we're going to create this meal and diet type object out of those values. So here I'm going to just emit meal and diet type. So this one. And here I'm going to basically pass those 4 different fields which we have defined here. So the first one is selected meal type. Okay, this one. Next is selected meal type ID. Next one is diet type. And finally diet type ID. Okay, so as you can see, this variable is basically a type of a flow, and this flow contains a meal and diet type object. And here inside this block map, we're basically retrieving those values from our data store preferences using those specific keys which we have already defined. And if there is no any data inside those specific keys, then we're going to return those default values. So in this case, for meal type, I'm setting a main course. For a meal type ID, I'm going to set 0, and for a diet type gluten-free and diet type ID 0. So this 0 basically represents chip ID. So if there is no any data, I'm going to pass those values, and if there is, I'm going to use those existing values. Okay, so there is one more thing which we need to add here. So we need to use our HILT library annotation to annotate our data store repository. So I'm going to use activity retain scoped. So the reason why I'm using this retain scope is because this data store repository will be used inside our recipes view model, and you will see later. So I'm going to basically use this data store repository inside this recipes view model in the next video. Okay, so one more thing, and inside this data store repository, I can use those 2 constants instead of this hard-coded values. So we have already created the constants for those 2 values. And if we open up this constants class, you will see that we already have this default meal type and default diet type. So we're going to replace those 2. Here I'm going to replace that with default meal type. So Alt plus Enter. And the second one with this default diet type. So just replace that. Alt plus Enter. And here for zeros, we are not going to create any constant for now. So that will be all for this data store repository for now. And don't worry if all of this might be still confusing. Everything will make more sense when we actually start using this data store repository inside our recipes bottom sheet. Hello there and welcome back. So in the previous video we have created our data store repository, and here we have one function for saving meal and diet types and their chip IDs, and down below we also have one variable which will basically read those values which we have already saved, and the type of that variable is a flow, and it contains a meal and diet type class which we have also created down below. So in this video it's time for us to inject this data store repository inside our recipes view model. So this is how our recipes view model looks so far, and we're going to inject our data store repository inside it. So here I need to use an annotation named view model inject. So we have already used this annotation, so you know. Then we need to add constructor keyword, and then after this application parameter I need to add one more parameter. So private vol data store repository. Okay, I'm going to reformat the code, and now it looks even better. So basically now with this annotation I have injected this data store repository inside our recipes view model. So inside this recipes view model, first I'm going to create one variable. So variable named read meal and diet type. And here I'm going to use this data store repository which we have already injected. So dot read meal and diet type. And the type of this actual value is, as you can see, flow of meal and diet type. And down below I'm going to create one function named save meal and diet type. So this function will have 4 different parameters, so we can actually insert all of those 4 values which we have defined inside our data store repository. So the first one is a meal type of a type string, then we have a meal type ID of a type integer, then we have a diet type of a type string, of course, and diet type ID of a type integer. Okay, so I'm going to say equals, and then I'm going to call a view model scope to launch Kotlin coroutine. So I'm going to use this dispatcher .io, and inside I'm going to call this data store repository and call its function named save meal and diet type. And here of course I need to pass those 4 values, meal type, meal type ID, then diet type ID. Okay, so basically we're calling that save meal and diet type function from our data store repository, and as you can see here it is. And with that function we are basically inserting the exact values from these function parameters. So basically now that we have this read meal and diet type variable here inside our recipes view model, we can just read that variable and display its values inside those queries here. Okay, and basically when we get back from our bottom sheet to our recipes fragment, we can just use those exact values. So here on the top I'm going to create two new variables. So private var, because we're going to change those values. So meal type, and their default value will be default meal type, so this one. And the second one, private vol diet type, and its default value will be default diet type constant. Okay, so after that inside this apply queries function I'm going to call a view model scope to launch a Kotlin coroutine, and here I'm going to also use this read meal and diet type, and I'm going to call this collect function, which will basically collect the values from that flow. And here I'm going to write value. Okay, and I'm going to collect those 2 values for meal and diet type, and I'm going to store them inside those 2 variables on the top. So I'm going to use meal type equal to value dot selected meal type. Okay, and the diet type value dot selected diet type. Okay, so now those 2 values on the top will get the values from our data store repository directly, and we can just copy and paste those values here. So instead of this default we can just type this meal and diet type. Okay, so this way we are going to get the newest values inside our apply queries every time. And of course if there is no any data inside those selected meal and diet types, then we are going to get their default values. And as you can see inside our data store repository, we have specified that if there is no any value, we're going to get that default value, which we have specified inside our constants class. So that will be all for this video. So don't worry if you're confused right now. There are some more steps which we need to finish in order to complete this recipes bottom sheet. And once we complete everything, we're going to recap each and every step once again, and everything will make more sense to you. So that's it for this video. Hello there and welcome back. So in the previous video we have injected our data store repository in our recipes view model, and here we have also modified our apply queries function, and here basically we are reading those 2 values and we are setting its values to those 2 variables here, and those 2 variables have a default value of course, but once we run this apply query their value will change, and we're going to get those values from this data store. And after that we're going to apply those 2 meal and diet types to our actual query right here. So don't worry if this sounds confusing. Once we handle our recipes bottom sheet, we're going to recap all of the steps which we already did, and everything will make more sense to you. So now we're going to open up our recipes bottom sheet, and here we're going to start coding. So the first thing I want to do here, I want to create one variable named mView, and I'm going to return this same variable, so mView. Okay, so now on the top I want to initialize our recipes view model. So we're going to use our recipes view model inside the recipes bottom sheet and in our recipes fragment as well. So this view model will be shared between those 2 classes. Okay, so here private late init recipes view model. Okay, so this one. So I'm going to press Ctrl O, and we're going to find onCreate method here. So we are going to override onCreate method. So let me just find that. Okay, so this one, click OK. And inside this onCreate, we're going to initialize our recipes view model. So recipes view model provider. Okay, so here I'm going to pass require activity dot get, and here recipes view model class dot java. Okay, so here we have initialized our recipes view model. So here now I want to create 4 different variables for meal type chip, diet type chip, meal type chip ID, and diet type chip ID. Okay, so you will see private var meal type chip, and its default value will be used from our constants class. So default meal type. So just press Alt plus Enter. Down below we're going to create one more. So this time meal type chip ID. So the default value for the chip ID will be 0. Next private var diet type chip, and here we're going to use diet type. So click Alt plus Enter, and finally private var diet type chip ID, which will be 0. So this ID basically represents the actual ID of one of those chips from our chip group, and you will see. So for now we only need those 4 variables as a global. So now let me open our bottom sheet layout. So let me find that. Okay, so recipes bottom sheet, and here you will see the IDs of our actual chip groups. So as you can see, the first chip group has the ID of meal type chip group, and the second one has the ID of diet type chip group. So now inside our recipes bottom sheet, we want to implement on checked change listener. So whenever we check one of those chips in our chip group, we want to store its value and its ID. And when we press apply button, we want to basically save that selected chip ID and its name to our data store. And we're going to do the same thing for our second chip group as well. So now let's open up our recipes bottom sheet. And inside this onCreate view method, we're going to use this mView to get the reference of our meal type chip group. Okay, so this one. And now I'm going to set on checked change listener. Okay, so here I'm going to write group as a first variable and selected chip ID as a second one. Okay. So here I'm going to create one new variable named chip, and here I'm going to use this group variable to find view by ID, and here I'm going to write chip, so that's the actual view, and inside the parameters I'm going to write selected chip ID. Okay, so basically this variable will hold our selected chip, and down below I'm going to create one more variable named selected meal type. And here I'm going to use this chip from above, then I'm going to get the text from that, then convert that to string, then to lowercase. And here we have a suggestion from Android Studio, so press Alt and Enter, and here choose this first option. So we can just add this local root. And now in this onChecked change listener, I want to basically set the values of those 2 variables on the top. So now from this onChecked change listener, I want to get 2 values, and I want to store them inside those 2 variables on the top. So first let's use meal type chip, and here I'm going to store this selected meal type. So basically inside this variable I'm going to store a string of selected chip. So for example, if we select this dessert, then the text of this chip will be stored inside this variable. And down below we're going to use a meal type chip ID, and here we're going to store a selected chip ID. Okay, and in this variable we're going to store ID in a format of integer. So whenever we select a new element from our chip group, there is a new ID of that specific chip, and that ID will be stored inside this meal type chip variable. And basically I'm going to add one more set on checked change listener, but this time for our diet type chip group. So down below let me use mView.diet type chip group, so this one, and I'm going to set on checked change listener. Okay, so this one, and here I'm going to repeat basically the same thing. So I'm going to create a new variable named chip. So I'm going to use this group variable from above, then find view by ID. Here I'm going to pass the actual chip here, and here I'm going to say okay, so I'm going to replace this checked ID with a selected chip ID. It makes more sense to me. Okay, so just pass that, and down below let's create a new variable named selected diet type, and here we're going to use this chip from above to get the text, to convert that to string, then to lowercase, and here I'm going to also use this local.root. Okay, and of course I'm going to store those two values inside those global variables as well. So now I'm going to use diet type chip to store this selected diet type, then diet type chip ID to store this selected chip ID. Okay, so basically now whenever we select one of those chips, we're going to store its ID and its actual text inside those four global variables. And we're going to use those four global variables to actually save the data to our data store, and you will see. So now what I'm going to do, I'm going to add on-click listener for our apply button. So as you can see, the ID of our button is apply button. So here we're going to use again this mView object dot apply button, so this one. Okay, and we're going to set on click listener, and from here we need to use our data store. So we have already initialized our recipes view model, so let's get a reference of that recipes view model, and from our recipes view model we're going to call this function named save meal and diet type, and this is a function from our data store repository, and here we need to pass four different parameters. So a meal type ID, diet type, and diet type ID. So now we're going to pass those values from those global variables. So now let's type here meal type chip, that's the first parameter, then we have meal type chip ID, then we have a diet type, and then we have a diet type chip ID. Okay, so those are our four different variables from the top. So basically when we open our bottom sheet and when we select one of those chips from each of those two groups, we're going to save them immediately in those four different global variables. And as you can see, we have already implemented this on-check change listener. So whenever we check one of those chips, it will save that chip ID value and the text in those global variables. And when we actually press our apply button, we're going to persist and save those values using our data store preferences. So there is one more thing which we need to add here. So far we have implemented the function to actually save those values, but now when we open our bottom sheet, we also need to implement a way to read the values from our data store, so we can actually apply them immediately to our chips here. And for that we're going to use our recipes view model to actually read the values from our data store. So here I'm going to use the recipes view model dot read meal and diet type, and since this is a flow, we want to convert that as a live data. And then we want to observe that live data. So here we need to pass lifecycle owner, and here we need to observe those values from our data store. And I'm going to name this variable value, so simple as that. And from this read meal and diet type, I want to get two values, and I want to store them inside those two global variables, meal type chip and diet type chip. Okay, so from here I'm going to use a meal type chip here. And here I'm going to store the value from our read meal and diet type. So I'm going to use this value variable and then selected meal type. So here I'm going to store that value inside this meal type chip global variable. And also I'm going to use this diet type chip to store another value, so value.selected diet type. So basically whenever we open our bottom sheet, this observer will be called, and we're going to get the values from this read meal and diet type. And I'm going to open that up so you can actually see. So read meal and diet type. Okay, so as you can see here, we're basically reading the values from those keys which we have already specified in some of the previous videos. And if there is no any data in those preferences with the specified key, then we will use a default value for meal type and the diet type. Okay, so let's open up our recipes bottom sheet now. And basically if there is new data in our data store, then we're going to get those values and immediately apply them to our global variables. And now we're going to use those two values which we're reading from our data store to actually make a selection on our chips with those actual values which we have saved. So now I'm going to create a new function here, update chip, and I'm going to pass two parameters here. So the first parameter will be values.selected meal type ID this time. So we are passing the actual ID this time. And the second one will be the actual chip group. So mview.meal type chip group this time. And now I'm going to basically duplicate this line one more, and this time I'm going to choose selected diet type chip ID or diet type ID, and here I'm going to choose diet type chip group. Okay, and down below I'm going to create that function. So here private fun update chip, and we are going to have two parameters. The first one is chip ID of a type integer, so chip ID of a type integer, and the second one chip group. Okay, so here we're going to check if our chip ID is not equal to 0. So our chip ID will not be 0 if we have made some selections before and we have saved that data to our data store. So if our chip ID is not 0, then we're going to use a try block to actually make a selection. So I'm going to use a chip group from our parameters dot find view by ID. Here I'm going to pass the actual view, which is chip, and here I need to pass chip ID. Okay, and I'm going to call this method named is checked. So is checked. Okay, and I'm going to set that value to true. Okay, and of course in a catch block I'm going to use exception, of course, and I'm going to just log an exception if there is one. So here recipes bottom sheet, and here I'm going to write e.message.toString, and that will be all. So I'm going to reformat this code a little bit. So basically now whenever we open our bottom sheet, we're going to read the values from our data store, and if there is a new data in our data store preference, then we're going to update our chips with those exact values. And of course here we have implemented the two on check change listeners. So whenever we select a new chip here, that value of those global variables will change. And finally, when we press our apply button, we're going to use this save meal and diet type function from our recipes view model to actually save those newest values to our data store. So now I'm going to run the app and see if all of that is gonna work. Okay, so now let's open our bottom sheet. And as you can see, default selection are main course and gluten-free. So now I'm going to select, for example, dessert, and from here I'm going to choose a vegan. So now we can click apply button. So we are not going to get back immediately to our recipes fragment because we haven't implemented the actual logic to navigate back, but don't worry about that, we're going to implement that feature in the next video. For now let me just manually close that, and now let's open that again, and you will see that that selection is now automatically applied. Okay, so now we can run our app again, and you will see that that same selection will be applied with no issues. Okay, so as you can see we have desert vegan, and we can change that to, for example, sauce ketogenic. Click apply. Then when we run our app again, you will see that that selection is automatically applied with no problems. Okay, so as you can see, ketogenic, and here sauce. So it works like a charm. And that will be all for this video. So if you are having troubles with understanding this code here, I highly suggest you to read once more this code and all the code previously which we have created inside this bottom sheet section. So in the next video we're going to implement the actual navigation so we can get back from our bottom sheet to our recipes fragment. And when we finish that, we're going to recap once again all the steps we went through in this bottom sheet section. So that will be all for this video. Hello there and welcome back. So in the previous video we have started coding in this recipes bottom sheet, and we have implemented all the necessary logic for us to actually save and read the values from our data store. So here, as you can see, we have implemented our two on-checked change listeners for our chip groups, and basically whenever we select a new chip from our two chips group, we're going to store those values inside those global variables, and when we press this apply button, we're going to basically save those values to our data store. And of course, on top of this on create view, we are observing this read meal and diet type variable or flow, and we are converting that flow to live data to actually observe it. And inside this observer, we are basically populating the values to our two global variables here. And we are calling this update chip function to actually update our chip to the newest data which we have saved. So now we need to implement the navigation. So basically when we click apply button, we want to automatically navigate back from this bottom sheet to our recipes fragment. And for that, first we need to open up this navigation graph. So let's open that up. And here, as you can see, this is our recipes bottom sheet. And we have already specified this action. So we have this action which says action recipes bottom sheet to recipes fragment, and we just need to use our nav controller to navigate from this dialog to our recipes fragment. But there is one more thing which I want to add here, and when I select this recipes fragment, I want to add one argument. So that argument will be a simple boolean value. So let me create one, and the name of this variable will be back from bottom sheet. The type should be boolean and default value will be false. Okay, so just select that and click add. So now our recipes fragment will contain this argument. So basically when we get back from our bottom sheet, we want to pass a value through this argument to true. So that means that whenever we get back from this bottom sheet, the value inside this argument will be true. And now let's open up this recipes bottom sheet, and inside this apply button on click listener, we're going to create one variable named action, and here I'm going to use recipes bottom sheet directions. So this class is automatically generated by our navigation component, and I'm going to press dot, then action recipes bottom sheet to recipes fragment. So that's the exact action which we have inside our navigation graph. So as you can see here, that's the same action right there. Okay, and inside the parameter of this function or this action, we need to specify our value. So here it says that there is no any parameter, and we have added already our argument here. So if you see this no parameter text here, that means that we need to rebuild our project. So let's click build, then rebuild the project, and now we should be able to see a new parameter appearing here. So let's wait. Okay, so when we press now Ctrl+P, and as you can see now this parameter will appear. So here we're going to type true. So whenever we get back from our recipes bottom sheet to our recipes fragment, then we want to pass this value to true, okay? And we're going to need that value later, so you will see. And the next thing I'm going to call find nav controller, and I'm going to use a navigate function and pass here that same action, okay? So after that we need to open up our recipes fragment. So let's find our fragment here. Okay, and here I need to create one more variable, and that variable should be named args. And I'm going to delegate that to nav args, and here I'm going to pass recipes fragment args. So this args is automatically added by our navigation component when we actually specified our argument. So this is automatically generated by a safe args plugin, and when we have specified that argument here, that class was generated. So if you don't see that class, then you should rebuild your project again. Okay, so we're going to use this args to access this argument which we have specified in our navigation graph. So down below inside our read database function, inside this first if block, we're going to add two ampersand symbols, and I'm going to paste here args dot, and as you can see we can get the access of this argument immediately. So back from bottom sheet. So here basically I want to check if our database is not empty and args.back from bottom sheet is false, and I'm going to set here this symbol. So basically if our back from bottom sheet is false, then only then we're going to load the data from our database, okay? And why is that? Well, you will see in the future. So basically when we get back from our bottom sheet, that means that we want to apply a new query to our GET request with the new values. So only if our back from bottom sheet is false, then we are going to read from database. And if that value is true, and that value will be true when we get back from our bottom sheet, and if that value is true, then we want to request a new data, okay? So every time we get back from our bottom sheet, we're going to request a new API data. And from our recipes view model, you can see that we have modified our apply queries function. And now from here, we are basically reading our data store preferences to get the exact values from our bottom sheet, okay? So from here, we're getting those values, and we're applying those newest values to our query. So that's how we are able to request a new data every time we get back from our recipes bottom sheet. So now we're going to test it out and see if new recipes will show in our recycler view. Okay, so now I'm going to uninstall this app and I'm going to install that again so we can actually start from the beginning. So let's remove that. Okay, and let's install our app once more. Okay, so by default we're going to request those recipes. So you can see main course gluten-free. Those are default recipes by our application. And now let's try and add new recipe types here. So let's choose dessert and let's choose vegan, for example. So click apply. And now you can see that we are back from our bottom sheet, and our request API data function was called, but this time with new data or new queries. So now we can check other different types here. So for example, let's choose vegan bread, click apply. And as you can see, we can see different kind of results. And we can check all other types here, for example, a drink, and so on, and everything works perfectly fine. So that will be all for this video, and in the next video we're going to recap once again all about this bottom sheet. Hello there and welcome back. So in this video we're going to recap once again everything what we did inside this bottom sheet section. So first, as you can see, we have started by designing this bottom sheet, and our bottom sheet here contains two different chip groups, and each chip group have multiple chips inside. So by default we have two selections. So the first one in meal type here is a main course, and the second one in diet type is gluten-free. So those are default queries which we have specified inside our recipes view model as well. So after we have designed our bottom sheet, we have created our data store repository, and inside this repository we have created 4 different keys for our preference. So we have a key for meal type ID, for diet type, and diet type ID. So down below we have also created 2 functions, or 1 function and 1 variable. So this function will be for saving or storing our data inside the data store preference, and the second one, a variable named read meal and diet type, will basically read our data store to get those values which we have already stored. And the return type of this variable is a flow of meal and diet type, and this meal and diet type class is been already created down below. So as you can see, that class contains 4 different fields, 2 strings and 2 IDs. So those 2 strings basically represents chip text, and those 2 IDs represent chip ID. So we have injected this data store repository inside our recipes fragment, and that's why we have annotated our data store repository with activity retain scope. Okay, so as you can see here, we have injected our data store repository right here, and we have also created a function for saving meal and diet type, and a variable for reading that as well. So now from our recipes bottom sheet, we have initialized our recipes view model, and here whenever we open our bottom sheet, we are reading those values from our data store. So basically, after we have read those values from our data store, we have stored those values inside our 2 global variables, meal type and diet type chip, okay? So those 2. And after we have stored those values, we are basically using this update chip function to update our chips. And down below you can check this function. So this function is checking if a chip ID is not 0, and the chip ID will not be 0 only if we have stored or saved our chip selection previously. And in that case we are basically applying that selection to our chip group. And also here we have applied those 2 unchecked change listeners, and whenever we open our bottom sheet and basically select one of those chips from here, we are storing its values like the actual text and the chip ID to those 2 global variables. So as you can see, meal type chip and meal type chip ID for meal type group, and those two diet type chip and the diet type chip ID for a diet type chip group. So only when we press our apply button, we are going to save those selection in our data store preference. And if we close this bottom sheet by clicking somewhere else on the screen, then this function will not be triggered and selection will not be saved. So that logic overall looks very nice and it works perfectly fine. So inside our recipes view model, we are applying those two queries for meal and diet type dynamically. So as you can see, we are grabbing those values from those two global variables, and its default value is default meal and default diet type, which are defined in our constants class, and their value will change when we call this apply queries function. And inside this function, as you can see, we are reading our meal and diet type from our data store preference, and we are storing those new selections inside those two values, and only then we are applying a new queries. So basically that means that whenever we get back from our bottom sheet to our recipes fragment, we're going to receive new queries and we're going to request a new API data. So basically that's it for this bottom sheet recap. So if you are still confused about this actual code, I highly suggest you to watch again this whole section about the bottom sheet, and for you watching it the second time, it will be a lot easier to process some things which you haven't in the first try. So that will be all for this video, and in the next video we're going to start by handling internet connection for our application. So you will see. And basically we're going to implement a connection listener. So whenever we lose connection, we're going to display here a toast message, and when we get back the internet connection, we're going to also display a toast message saying we are back online or something like that. So for this video, that will be all.